Bismillahirrahmanirrahim. Assalamu alaikum. Today's lecture is about the chain drives. In our previous lectures, we have covered the drive systems. Initially, we have covered the belt drives, and then we switched to the rope drives. इन दोनों के lectures मैं already आपको दे चुका हूँ. And today's lecture is about the chain drives. Okay. So, first of all, giving it a short introduction about the chain drives. Chain drives are basically used for the high powers as compared to the belt and the rope drives. The chain drive system initially consists of minimum of the two sprockets. Sprockets are in the same. They are more or less the same as the spur wheels are, but the difference is that the spur gears mesh with one another. The sprockets do not mesh, they are at a distance, and there is a difference of the thickness of and the tooth profiles between the sprocket and the gears. So the difference between the gear and the sprocket will be quite clear for you people. Now the chain system is consisting of initially minimum number of two sprockets, and there is a chain that is mostly metallic, and sometimes it's made of the cast irons, sometimes it's made of some alloys. It has a different types. So these three systems, when meet with one another, they form a chain drive system. Chain drive systems are very efficient when the distances are not so long. Even if the distances are long, they work good. Why the chain systems have been invented. The reason for this for invention of the chain system was that in the rope and the belt drive there is a chances of slippage. So slippage cause wear and tear. But in the case of chains, the slippage is minimum, so the efficiency is high. The chain drive systems are more efficient than the previous two belts and the rope drive systems. Okay. There are a lot of applications of these chain drive systems. You can see it in your bicycles. Mostly it's in motorcycles, then there are agricultural machinery, road rollers, etc. There are cranes, there are hoists. So you can see a lot of applications of chain drives. So starting with the simple chain drive mechanisms. In the diagram at the left top corner, you can see that there is a sprocket, then there is a pedal gear. Okay? These both are initially sprockets. This is the system you can easily see at your bicycles, where there is a driver, which is basically the human force that drives the wheel at the back side. That is the driven one. In a bicycle, you know this thing, that only the rear wheel is driven, the front wheel is free to move. Okay? So this is at the left top there is a simulation how your wheel works. So if you see it in a 3D or 3D version, you can see the diagram at the right. On the right side, it's the same system. You can see there are two sprockets, and then there is a chain, a specific chain mechanism, and this chain is being run by the driver. Okay. Next one. Okay. Sometimes it is not mandatory that you have only one driver and one driven sprockets. You can have lot of more options than this driver and the driven. For example, you can see over here that there is another sprocket that has been placed in between the two. Now the purpose of the other sprocket is to give multiple drives from the one source. You can take two shafts out of it and run the two independent systems. Now there comes another thing that it could also be used, an extra sprocket can also be used to adjust the tensions so that the efficiency is increased. But in most cases where there is only two sprockets, Yes, then there is no need of this third one. Reason being that this third one will go into the loss of the power. You don't need it. You can just adjust the chain drives, and you can manage by calculating the forces that are at the slag and the tension side. You can easily adjust it. So there is no need to place the third one. However, if you want two drives or more than two outputs, you will go for this type of chain sprocket mechanisms. Right. The next one is the simple animation that is showing you that how the engine provides the power to a sprocket, and then that power is transmitted to the chain drive, to the output system. That could be the wheel of the motorbike, or that could be the other agricultural machinery. Now, the interesting thing is that they have placed an sprocket over here, extra sprocket over here, that is creating, that is maintaining the tensions in the chain. Now, why they have used it over here? When they don't need it, they can adjust the chains. Reason being that this is the system that is being used by most of the heavy bikes, where you need to transfer a lot of RPMs. So for a lot of RPMs to align the chain so that it's not broken, it's not disrupted, you need these type of sprocket. Okay, if we go for the post-mortem of the chain, roller chains, that is the most common one, because they are good power transmitters. तो अगर आप इसको चीज़ को देखना चाहें कि ये जो रोलर चेन्स हैं ये किस तरह से डिज़ाइन की जाती हैं, या इसका जो मैकेनिज़्म है वो क्या है, सो यू हैव टू disassemble it. When you will disassemble it, you will find lot of parts over here. The first part would be the outer plate, then there will be a bearing pin over here, there will be a bush, and there will be a roller over there, and obviously there will be plates, both consisting inner and the outer plates. So all these things combine and they form a roller chain that works. So you can easily make a guess that when you are making this, or when you are assembling this chain mechanism, then then it has a lot of flexibility, because the length of the linkages are small. However, the pitch and the distance that the chain travel is not the same. For that case, we take some good measures that I will discuss in my upcoming lecture. Okay. Now, previously we have seen that there are two sprockets and there are three sprockets, and they are working independently. However, there are some other sprockets in which you can have a triplex chain, or you can go for a 4 chains and 5 chains. Now, what's the functionality, or what's the difference between this thing is that from this type of system, you can take the 3 independent outputs. Number one, if you change the system, if you change the dia of the sprocket, that is mostly in this case the dia is the same. Three of the sprockets are giving the same output. But if you change the dia and you change the configuration of the sprockets, you can get multiple outputs. The best example for this is your bicycles, your gear bicycles, in which by changing the gear you just do nothing, you just take the chain and adjust it to a required sprocket. जब वो छोटी स्प्रॉकेट पे चल रही होती है तो स्पीड कुछ और होती है, और फिर उसके बाद तो जब उसको बड़ी स्प्रॉकेट पर ले जाते हैं तो फिर स्पीड कुछ और होती है. सम गिव यू मोर पावर. अगर आप स्पीड पर चढ़ाना चाहेंगे तो आपकी जो छोटी स्प्रॉकेट्स हैं इस तरह की चीज़ उस तरह से नहीं चलेंगी, तो उसको आप चेंज करना पड़ेगा. एंड मल्टीपल थिंग्स यू कैन सी इट ईजिली फ्रॉम योर गियर बैग्स. ठीक है जी. Okay, so there is a simple video. If you want to do some work using the chain mechanisms, you can go for a simple project. It's a simple project by some engineer, I guess. No, the first thing that is to be taken care of in the case of chain drives is that you cannot get a soundless transmission. Chains are noisy transmissions. Uh, reason being, reason being that when the chain is metal, sprockets are metal. So when the chain revolves around a sprocket, it meets and they are in tension. When in tension, they strike with one another, and in this striking, the the pin joints are also creating some noises, pin joint noises, sprocket noises, striking noises, and some extra noises that are between the different linkages of the chain. They all create a messy environment when the chains are working. So let's see what the project says.
Just finished making a compound gear reduction chain drive system for my grain mill, which I use in home brewing. And it is made out of bicycle chain and a cassette off the rear wheel on the bicycle. And it's about a 9.68 to 1 gear reduction. And it powers the mill, which cracks my grain, and it comes out down here. And I run it with a drill.
So you have seen that it's basically a gear reduction system और उसकी एक एप्लीकेशन एक हाउस होल्ड एप्लीकेशन इट्स अ सिंपल प्रॉब्लम सॉल्विंग केस इन विच द मैन हैज़ मेड अ ग्रेन क्रशर जिससे वो ब्लेड्स लगा के उसको चला रहा है और चला के वो ग्रेन्स को यहाँ पे वो क्रश कर रहा है या आटा बना रहा है एंड वट्स एवर जो कुछ भी है ठीक है विद दिस टाइप ऑफ थिंग्स यू कैन मेक योर ओन एप्लीकेशंस एज वेल आप इसको किसी और चीज़ के लिए इस्तेमाल कर सकते हैं यू कैन मेक अ वॉशिंग मशीन दैट कैन बी रन विद योर साइकिल इट्स अ वेरी सिंपल प्रोजेक्ट वो आपकी एक्सरसाइज भी हो जाएगी एंड इट विल आल्सो वॉश द क्लोथ्स इफ यू वांट टू डू इट और यू कैन टेक सम अदर एप्लीकेशन कोई कीमे की मशीन बना सकते हैं किस तरह की चीज़ बना सकते हैं दैट इज़ अप टू योर लेवल के आप उसमें इसको किस जगह यूज़ करना चाह रहे हैं ठीक है ओके सो द नेक्स्ट वीडियो विल बी टूवर्ड्स द प्रॉब्लम सॉल्विंग ठीक है होता ये है कि अगर आपकी चेन प्रॉपर टेंशन उसमें अगर क्रिएट ना की जाए तो उसकी क्रिएशन टेंशन ना होने की वजह से जो चेन है वो अपनी जो इट स्टार्ट्स वेयरिंग आउट अब वेयरिंग आउट में क्या होता है कि वो चेन जो लूज़ होती है इस वजह से वो जो स्पेसिफिक फोर्सेस ट्रांसमिट करनी चाहिए वो नहीं कर पाती उसकी वजह से प्ले आता है प्ले रिपल्स प्रोड्यूस करेगा रिपल से क्या होगा जो सर्फेसिस हैं आपकी चेन की वो स्प्रॉकेट की सर्फेसिस के साथ लगेंगी दोनों के साथ जब लगेंगी तो फिर दोनों में वियर आउट होगा और वियर आउट होने के बाद फिर उसकी जो लाइफ है वो उतनी नहीं रहेगी सो देयर इज़ सोल्यूशन टू इट दैट इज बीन एक्सप्लेन्ड इन दिस वीडियो सी
I'm Bill Sawicki, National Account Manager for Command Industrial Technologies, with over 25 years of experience in the power transmission industry. One of the issues I hear a lot from our customers is slippage of their chain drives, which causes premature wear, failure, and unplanned downtime. Today, I will show you how to properly install roller chain sprockets and the proper tensioning of roller chain. By following these steps, you can vastly extend the life of assembled drives and ensure better performance of your power transmission system. For sprocket installation and tensioning, we're going to use 2 Martin roller chain sprockets with set screws, steel key stock, roller chain, a hex wrench, straight edge, and a tensioning scale. First, we're going to install the sprocket on the drive shaft. Then we'll take our key stock and insert it to lock the sprocket onto the shaft. We'll want to slightly tighten the set screws for now and come back and tighten it more after we check the tension. Next, we'll install the second sprocket. Insert the key stock to lock the sprocket onto the shaft. We'll slightly tighten the set screws, and then we'll attach our roller chain of the appropriate length. Make sure the ends of the chain are lined up with the sprocket, and we take the pins and plate from our master link and slide them in the chain ends. Next, slide the plate over the pins and attach the clip to secure the master link. Now we're ready to check the chain tension. Excessive chain sag can cause vibration or excessive noise and prevent the chain from properly engaging the sprocket, which can prevent the chain from operating smoothly. On the other hand, an over-tightened chain can cause premature wear or elongation of the chain and lead to increased replacement costs. On the slack side of the chain drive, we'll place our straight edge from sprocket to sprocket. From the straight edge, we can use our tensioning scale to measure the amount of sag from the straight edge to the chain. For most applications, chains should be installed with sag between 2 to 4% of the sprocket center distance. Once we ensure proper tensioning, we'll fully tighten the set screws on the sprockets and apply lubrication to the chain in accordance with the chain manufacturer's recommendations. A critical step in maintaining equipment with roller chain and sprockets is to routinely inspect drives for correct chain tension. You can also routinely inspect roller chain for elongation using a gauge which compares the true chain pitch to the original pitch. Most chain manufacturers recommend replacing the chain after 3% elongation. After this amount of elongation, the chain rides up on the tooth sprocket, altering the pitch of the tooth. To ensure optimal part life and avoid unexpected downtime, you should replace the sprockets each time the roller chain is replaced. You can also consider options such as hardened sprocket teeth, which provides additional wear life. This is especially helpful for driver sprockets and when ratios exceed 3 to 1. If you need any more information about quality roller chain sprockets or alignment techniques, please contact your local command representative. We have the products and expertise to avoid costly, unplanned downtime.
Okay, so in this video you have seen that if you want to adjust the tension in the chain, how you can do it. Plus, if there are some maintenance problems and you want to reduce the downtime, you want to reduce the maintenance work at your downtime, then you can go for the regular inspections. In regular inspections, the person over there has told you how you can inspect the chains, how you can expect the sprockets. With the proper maintenance, you can increase the time of working for the chains. Okay. So after a brief introduction to the chains, you must be in a position to grasp the advantages and disadvantages of the chain drives. Okay. So I have chalked down some of the major advantages and disadvantages in this slide. There is no slippage. It's obvious. I have already told you that when you will go for the chain drive, will be no slippage as you are using the metal, so the strength is very much increased. They are very good when you are even going for the shafts that are very near to one another, and they have very good transmission efficiency, that is 98%. It's very good. And the chain basically it gives the less forces on the shafts when they run, and they have the capability to transfer the motion to several shafts. So what are the disadvantages over here? Disadvantages are that because they are made of the metal and they are there is an assemblage, so they are quite costly. And they need proper maintenance and proper assemblage. Without that, they will not work. And secondly, if you have not maintained the tension, then you will have to see the problems that will be related to the velocity fluctuations. Okay, so let's familiarize ourselves with some regular terms that will be used for the analytical modeling and understanding the chains. So the first one is the pitch. Pitch is the distance between the two centers of the hinges. You can see from the cross-sectional view of the picture at the left side, that the distance between the centers of the two hinges that are also connected with the linkages, it's called the pitch. And if you trace if you trace the position of the particular pitch when you revolve your sprocket, you will get a circle, and that circle is called the pitch circle diameter. Now to uh, to go for the analytical modeling of the chain drive, you consider this pitch circle to be a polygon. With that polygon and with the trigonometric relationships, we will go for the analytical and the kinematic equations that will be used to find out the velocities and to find out the position of the chains. Okay, so the next topic is you have to study the relation that is between the pitch and the pitch circle diameter. Okay, so in the diagram over here at the right side, you can see that for the analytical modeling, the circle has been replaced or they have been assumed to be a polygon, and with the with the 2 points A and B have making an angle theta. The dia has been shown over here, and they all are concentrated towards the center O, and the length of the chain will be AB, and the A and B both are the hinges basically, right? Okay, so if we want to find out the dia, that will be dependent on the different parameters. We will go for the simple calculations over here, in which the D is the dia of the pitch, T is the number of the teeth, and with the trigonometric relationships we have find out the relation between the pitch that is dependent on the diametral pitch and a sine of theta by 2. So by resolving at the end, we got an expression of the diameter of the pitch circle that is directly proportional to the pitch and inversely proportional to number of teeth. Okay, so after finding the relationship between the pitch and the pitch circle dia, we will go to the velocity. The generic velocity formula that will be used, tangential velocity formula that has been used over here is v is equals to r omega, where omega is the speed of the sprocket that is revolving, and it has been connected to the shaft with the help of the bearings, and OA is the center distance from the center to the respective respective chain linkage that has been shown over here. That is V is equals to omega into OA. And if you want to resolve it for the diagram, it is for the diagram number A, and if you want to seek the velocity but further dividing it into the two parts C and D, you can also do it, and in that case it will be theta by 2. Now coming towards the kinematics of the chain drive. So if we assume that there is a chain drive, there is a chain connected between the two sprockets, one is the driving and one is the driven. The driving one is the left one and the driven one is the right one over here. So the initial position is A, B, O2 and O1. If we move the sprocket anti-clockwise, the point A will become A1 and the point B will become B1. So in this case, if you see, you can assume yourself that this is a simple case of 4-bar mechanism. What is 4-bar mechanism? 4-bar mechanism is a simplest mechanism that you people already have studied in your mechanics of machines course, in which there is one ground link, there is a crank, there is a rocker and there is a coupler. So if you see in this case, we have a ground link O1 to O2, Then we have a crank over here that is driving, that is O1 A1, and then we have a coupler link over here. We can assume a coupler link over here, A1 and B1, and then again we have a B1 and O2 as a rocker. But in this case you must have studied that if your rocker is capable of taking a 360 turn, then it's not a rocker, it also became a crank. So the chain drives is a assumption of 4 bar mechanism. In fact, it's a 4 bar crank mechanism. So with that equations, using 4 bar equations, you can also solve for the velocities and accelerations. Now if we want to find out the velocity ratios between the two sprocket, we can solve it with the help of the instantaneous centers. Instantaneous center concept you must have known from your dynamics and mechanics of machines course. So if we solve the system for the instantaneous center case, we will get a simple equation, that is omega 1 into O1i is equals to omega 2 multiplied by O2i. Now you can see that the instantaneous center will change with the position of the two sprockets, and in this cases when the distance O1 I1 will be minimum, the velocity ratio will be maximum, and the velocity ratio will be minimum if we have the distance O1i maximum. So that's the generic equation that we will get is omega 1 by omega 2 is equals to 1 plus O2 O1 by O1 and instantaneous center. Now classification of chains. All just we have studied up till now was introduction, brief introduction, and then we have seen how we can go for the simple modeling of the chains, and now we are going to classify different chains. The three basic types that will be studied over here will be hosting and hauling chains. The number 2 will be the conveyor chains, and number 3 will be the mostly used and the most efficient chains that are power transmitting or driving chains. Now from the now the first one is hosting and the hauling chains. Hosting and hauling chains, they are these are the chains that are most commonly available or you people have seen in the market with some usual hardware shop. These chains are made with the help of different rings that are oval in shape, and then they are coupled together and welded. They all form a hosting and a hauling chain type, that is with the oval links. ठीक है, इस तरह की chains जो हैं they are the most common, they are the cheap ones और ये आपको easily available हो जाती हैं. They are used for the carrying of some load, like say जिस तरह आप गाड़ी के अगर इसको गाड़ी को डिसम्बल करते हैं तो आप उसके इंजन को इसी चेन्स के थ्रू आप उनको उसको हैंग कर लेते हैं एंड देन यू ट्रांसपोर्ट दिस इंजन टू सम अदर केसेस. ठीक है, और यूजुअली अगर आप इसको देखेंगे अपनी लाइफ में इस्तेमाल होते हुए तो आपको जो चेन्स नज़र आएंगी फॉर नॉर्मल यूजेज वो इसी तरह की होंगी. दे कैन नॉट बी यूज्ड फॉर द हाई स्पीड्स. ऐसा नहीं है कि उसको थाउजेंड्स ऑफ आरपीएम के ऊपर आप इसको फिट करेंगे और ये चेन चल जाएगी, ये ऐसा नहीं चलेगी. ये लो स्पीड चेन होती है और ये नॉइज़ी भी होती है, और इसकी जो कॉमन एप्लीकेशंस हैं वो मैंने आपको बता दी हैं कि ये आपकी होस्ट्स में इस्तेमाल होती है और जो मैरीन एप्लीकेशंस हैं जहाँ आपने एंकर्स लगाने होते हैं सी के अंदर, हम उनको उस जगह पे इन चेन्स को यूज़ कर लेते हैं. दे आर वेरी एफिशिएंट इन सर्टेन केसेस. जी, द सेकंड वन इज़ द with the scare links. This is the chain with the scare links, and it has a scare type of linkages that are attached to one another. It has the specific applications like the previous one in the hosts, crane and ब्रिजेस एंड ये तीन चार कॉमन एक एप्लीकेशंस हैं जहाँ पे आपको नज़र आएंगे और दिस इज़ more power transmitting chain as compared to the previous one, but the problem is that if it will go for the a certain overloading, it will suddenly break or इसमें breakage will be in the form of specific kinking. ठीक है, so क्या होगा कि जो आपका स्केयर है ये डिफॉर्म हो जाएगा और डिफॉर्म होने के बाद आपकी जो ऑपरेशंस हैं उसके वो सारे के सारे इससे ख़राब हो जाएंगे. ठीक है जी. नाउ द नेक्स्ट topic or the next type of chains is the conveyor chains. Now, as you can see from the word conveyor, these type of chains are used for conveying the loads or the materials. It has a certain two types. One is the hook type and the other one is the closed joint type chains that has both been shown over here. They are made of cast irons and these chains do not have the smooth running qualities over there. अगर आप इसमें चाहते हैं कि इसमें नॉइज़ ना हो और ये प्ले ना प्रोड्यूस करे तो इस तरह की चेन्स नहीं इस्तेमाल होती. नॉर्मली यू हैव टू गो फॉर द power chains. They cannot be used for the high speeds. They cannot be used for the smooth operations that are noise free and maintenance free. But for certain low applications or certain applications, they are quite efficient and they are not as expensive as your power chains are. Okay, so the next one is the main topic in which we will be going to study the power transmitting chains. Now, with the advent in the technology or with the research going on, the first chain, that power transmitting chain that was designed was the blockchain या bush chain भी इसको हम क्या देते हैं. They were fabricated earlier और with that fabrication they have smoothened the way to the final product of chains that we can see in our life. ठीक है. Okay, but since it was the initial one, so it was also noisy. ये भी मतलब कि स्मूथ ऑपरेशंस के लिए हम इसको इस्तेमाल नहीं करते थे क्योंकि जो इसके टीथ हैं और स्प्रॉकेट हैं जब वो आपस में मेट होते थे तो उसकी वजह से उसमें दे प्रोड्यूस अ सर्टेन टाइप ऑफ नॉइज़. So it don't have the smooth operations from the noise point of view. The next chain that you usually see in your bikes or in your bicycles is the bush roller chain. So it is the same chain जिसका मैंने अभी पीछे आपको एक्सप्लोडेड व्यू दिखाया था. और जो ये चेन्स हैं ये असेंबली से बनती हैं और असेंबली इसमें किस चीज़ की होती है. एक आउटर प्लेट होती है, इसमें इनर प्लेट्स होती हैं, इसमें पिन्स होती हैं, बुशेस होते हैं और रोलर्स होते हैं. सो विद द प्रॉपर असेंबली ये लिंकेजेस बनाए जाते हैं एंड दीज लिंकेजेस आर देन कनेक्टेड टू वन एंड अदर टू फॉर्म अ चेन. They are very good from the transmissions point of view. They don't have much noise as compared to the previous ones and they need lubrication, but the lubrication is not aggressive and the wear and tear of these type of chains is less, and the one thing that is they are quite self-adjusting also. So the next chain is the inverted tooth or the silent chain. Now in the silent chain the main thing that comes out to be that they do not produce the noise. Reason being that they have such a mechanism that adjusts the pitch of the linkages when they meet with the sprocket. अब स्प्रॉकेट के साथ इसकी जो वो लिंकेजेस जो कि इंटैक्ट आते हैं, तो इनकी चूँकि उसमें स्प्रॉकेट के साथ टेंशन्स बदली होती हैं, सो द पिच जो है वो वेरी करती है। उस पिच की जो वेरिएशन है उसकी एडजस्टमेंट इस किस्म की जो चेंज हैं उसमें ऑटोमेटिकली हो जाती है, जिसकी वजह से जो नॉइज़ प्रोडक्शन है उसकी वो अल्टीमेटली कम हो जाती है। बट these type of chains are a bit expensive than the previous one. Okay, so the topic, the next topic is the length of the chain. We are quite interested before designing the chain drive chain system, that what is the length of the chains. So for the length we can have a simple relationship that has been derived for any of the belt drives or any of the road drives or any of the chain drives. But the terms over here R1, R2 and the X and etc., that will be different for the case of chain drives. So let's familiarize ourselves first of all with the different terms over here. There are two sprockets with a chain connected. The distance between the two hinges is the pitch, and then we have different radii with the two circles. Then we have a distance between the two centers O1 and O2. Now from now on we will derive the different terms based and we will this is the master equation that we will be using for finding the length. Let's find the terms over here, different expressions. Now T1 is the number of teeth of the largest sprocket, T2 is the number of teeth for the smaller sprocket, P is the pitch, and then we have the diameter of the pitch circle that has been derived earlier with the simple relationship between D and the pitch. So for the largest sprocket we have R1, and for the smaller socket we have the R2 over here. The P has been divided by 2 because we are using radii over here, not dias. So with the relationship in which we have pi R1 plus R2 is equals to half of the pitch into T1 plus T2, and with this relationship we will plug the values of R1 and R2 and pi R1 R2 into our primary equation. The length would become like this one, and with the relationship between the X module and the pitch, we will be substituting this thing in this equation, and with the things over here like teeth over here, module, and thetas, and then obviously number of teeth and the module. With this relationship we can easily find out the length of the chain. Now the first thing that is to be seen over here that I missed is that if we are using this equation, then it could also be directly applied to find the length. ठीक है, अगर हम चाहते तो हम डायरेक्टली इसी तरह से हम इसमें प्लगिंग करते और हम अपनी जो टर्म्स हैं फाइंड करते थे, लेकिन वो एक्यूरेट नहीं होती। उसकी रीजंस क्या हैं? उसकी रीजंस ये हैं कि हम जो यहाँ पर एजम्पशन कर रहे हैं पॉलीगॉन की, उस पॉलीगॉन की एजम्पशन की वजह से जो हमारी परसेंटेज ऑफ एरर है वो इंक्रीज होती है। चेन सर्कुलरली मूव कर रही है, हम पॉलीगॉन को यहाँ पे कंसिडर कर रहे हैं, so obviously there is an allowance. So with that allowance we can we need to improve this thing for getting a less type of error. तो हमने इस वजह से फिर इसको सर्कुलर एज्यूम करके हमने ये जितनी भी डेरिवेशन की है ये सब उसके लिए, ठीक है जी। So coming to the numerical side of this lecture, हमने जो मेन चीज़ें पढ़ ली हैं अभी तक वो हमारी बेल्ट्स हैं, सॉरी चेन्स हैं, और इसमें हमने डिफरेंट टाइप ऑफ चेन्स देख ली। वी आर प्राइमरी फोकसिंग ऑन द पावर ट्रांसमिशन चेन्स जो कि हमने अभी यहाँ पर पढ़ी है, ठीक है। सो वी विल बी डूइंग न्यूमेरिकल ओवर हियर, and in this numerical the author is saying that there is a chain drive that is being used for the reduction of speed from the 240 rpm to 120 rpm. Number of teeth have been defined, that is 20. We have to find the number of teeth on the driven sprocket. and if the pitch circle diameter of the driven sprocket is 600 and the center to center distance between two sprocket is 800, you have to determine the pitch and length of the chain. ठीक है जी. सो जितनी चीज़ें हमें यहाँ पर गिवन है हमने यहाँ पर लिख ली हैं और हमें T2 इसमें पहले फाइंड आउट करना है. सो विद द सिंपल रिलेशनशिप ऑफ N1 and T1 is equals to N2 and T2 we can easily find that T2. Now the pitch of the circle can be found by the simple relationship in which we have been given with the diametral pitch. The diameter of the pitch circle that is 600 millimeter. उस रिलेशनशिप से हम यहाँ पर पिच निकाल लेंगे. दैट कम्स आउट टू बी 47.1 mm. And then to find out the length we have to first of all find out the radii of the driving sprocket, that is R1, and that comes out to be 150, and from the x is equals to MP we can find out the module that comes out to be 16.98. So when we have find out all the factors over there, so finding all the factors we have plugged the values in the relationship of the length of the chain, so that comes out to be 3.06 meters. Okay? So with that we can find out the length and the unknowns that have been used to find the analytical relationships. Okay? So this is the end of the lecture, and in this lecture we have covered the last topic of drives, that is our chains. Right, so if you have any questions you can contact me in the interactive hour that will be on Wednesday 9:30 inshallah. Okay. Thank you very much for listening. Allah Hafiz.